with artificial intelligence, we are summoning the demon. You know those stories where there's the guy with the pentagram and the holy water, and he's like, yeah, you sure you can control
In the
it?
vast universe of technology, where artificial intelligence is like a kind of modern spell, epic stories of control and consequences arise. Universal Narratives presents The Digital Demon. From programming to quantum computation, NASA recently launched an extraordinarily powerful quantum computer. However, the abrupt shutdown of this technological marvel shook the world. What happened to NASA's quantum computer? A mystery shrouds this unexpected breakthrough. Join us in this exploration of the unusual as we seek to understand the implications of this event for the technology industry and the world at large. Discover with Universal Narratives the meaning behind the mysterious shutdown of NASA's quantum computer and how it could shape the future of technology and our existence. One of the most phenomenal milestones in the history of technological evolution has been the advent of digital computers. From early models like the ENIAC to later ones like the Macintosh PC. Each new generation of computers has brought transformations and enhancements in line with core human and communication technologies. With the advent of the Internet, information and communication technologies, ICT, have undergone a transformation on a global scale, turning what seemed impossible into a tangible reality. Today we face another massive revolution, artificial intelligence, AI. As more and more AI labs produce tools that span different technologies, it is undeniable that our world will take on a new shape in the coming years. However, AI is not the only next big thing in progress. There is another huge development that could bring about an even more significant change in our world once it is fully operational: quantum computers. Imagine a definitive computer capable of solving problems faster than you can imagine, leveraging quantum mechanics. Such computers could perform impossible calculations, make astonishing predictions, and perform a wide range of incredible tasks. Currently, there are many quantum computers in universities and various technological laboratories around the world. However, these are just scaled-down versions and barely scratch the surface of what is possible with quantum computers. According to Michio Kaku, a renowned physicist and author, all the big tech companies are currently involved in a race to perfect quantum computers. However, there is a dark side to this race. An advanced quantum computer could break any digital code, hack any system, evade any password, becoming the perfect machine for hacking. Imagine what could happen if such power fell into the wrong hands. This is one of the reasons why billionaire investor Elon Musk has criticized and warned tech companies, like Google, for their excessive emphasis on AI and quantum computers. Furthermore, the FBI, CIA, and other high-level government agencies around the world are monitoring every news or progress regarding quantum computers. Once the ultimate quantum computer is born, no one will be safe. Add to this the growing fear of an AI invasion, and you can see that there is a lot of uncertainty in the future of humanity. But all this does not change the fact that there are also many benefits. Quantum computers represent the next generation of computers, so it is natural for them to become a reality. To understand how quantum computers work and what makes them special, we need to look at them more closely. Quantum computers operate according to the principles of quantum mechanics. While traditional computers store data in bits, which represent 0 and 1 in binary form, quantum computers use qubits. These qubits are more sophisticated because they can hold data both as 0 and as 1 simultaneously, thanks to a unique ability called superposition. As a result, quantum computers can handle complex calculations in parallel, thus speeding up tasks and processes beyond what is currently possible with ICT technologies. Another fascinating thing in quantum computing is the property of entanglement. Entanglement is the connection of multiple qubits, where multiple qubits share a single quantum state. This property allows two or more quantum systems to correlate so strongly that any new data or information related to one is automatically updated to the other, regardless of the distance between them. This is one of the miracles of quantum computing. By harnessing superposition and entanglement, quantum computers can perform impossible tasks or process a large amount of data simultaneously. Quantum computers truly are the computers of the future. But how did the idea of these computers come about and when? As mentioned earlier, the entire idea of quantum computers is based on quantum theory, which deals with the behavior and energy of matter at the subatomic level. The concept of the quantum computer dates back to the 20th century, when scientists first developed quantum theory. However, given the low level of technology at the time, there wasn't much that scientists or scholars could do on the subject. Developing a simple quantum mechanics system was a huge problem, let alone developing an advanced quantum computer capable of processing data. It was not until the mid-90s that significant improvements in the concept of quantum mechanics began to be seen. In 1935, Albert Einstein introduced a unique concept called the EPR paradox, which helped explain the concept of entanglement between particles. However, the real breakthroughs did not occur until the 1980s. In 1982, the idea of quantum computers was born thanks to physicist Paul Benioff. He described these computers as machines capable of harnessing the power of quantum mechanics. From that moment on, the scientific and technological community became enthusiastic and impatient to see this dream come true. In the 90s, significant progress was made in understanding the basic principles of quantum mechanics. In 1998, a team of researchers at Los Alamos National Laboratory created a small quantum computer with 2 qubits, using nuclear magnetic resonance techniques. Although it was very limited compared to what one would expect from an ideal quantum computer, it was nonetheless a significant milestone for the scientific community. By the 2000s, many tech companies and research groups had begun working on their quantum computers. In 2001, the International Business Machines Corporation, IBM, invented the IBM qubit, a 7-qubit quantum computer capable of solving problems and calculations insoluble at the time. In 2005, a research team at the University of Innsbruck and the National Institute of Standards and Technology built a working quantum computer with 5 qubits. In 2007, another phenomenal milestone was reached, with researchers at Yale University creating stable qubits with the help of solid-state systems. In 2010, the Chinese University of Science and Technology achieved quantum teleportation, that is, the ability to successfully teleport information from one quantum qubit to another 1,000 miles away. In any case, these were significant advances, but they were not yet sufficient to reach the maximum potential of quantum computing. The culmination in the evolution of quantum computers came in 2013, when Google partnered with NASA to create something revolutionary: the D-Wave. The D-Wave was a revolutionary invention that not only surpassed all classical computers of its time, but also surpassed every other previous quantum computer. Moreover, NASA and Google had planned to commercialize the D-Wave, selling it to anyone who could afford it. However, just as the project was gaining momentum, something unexpected happened. The government intervened and asked to shut down the project. Thus, NASA had to shut down the project with no hope of when it might reopen. The unexpected closure dealt a heavy blow to this project, cutting short NASA's dream of exploring quantum technology. You might wonder why NASA, a space agency, is so interested in quantum computing. The answer lies in the potentialities of a supercomputer. A supercomputer could literally transform NASA's space exploration missions. Sending probes and astronauts to specific places in space requires a series of complex mathematical calculations. Before NASA could land the first men on the moon for the Apollo mission, a NASA mathematician named Katherine Johnson had to invent a new type of mathematics. A similar situation occurs for other space missions. Everything has to be calculated considering various factors. A calculation error could send a space probe in the wrong direction or make it collide with an asteroid in space. That's why quantum computers would be of great help in planning space missions, optimizing trajectories, and ultimately increasing the success rates of missions. Currently, NASA is working on applying generative AI in space exploration processes. However, these AI systems might have difficulty distinguishing between what is right and what is wrong, making wrong predictions. Quantum computers, with their ability to handle complex calculations, would be ideal for astronomers and cosmologists. Moreover, quantum computers could perform complex astronomical simulations faster and with greater precision, giving NASA experts a greater understanding of celestial bodies and how the cosmos works. Moreover, cryptography, an essential component of space exploration, will see a revolution when quantum computers are fully launched into the scientific community. But there's another reason that makes NASA desperate for an advanced quantum computer. A strange theory has always fascinated NASA scientists, and the only way to test this theory would be to use a quantum computer. For a long time, NASA scientists and people around the world have been looking for tangible proof of the existence of aliens, beyond UFO sightings and other oddities. Why hasn't there been any real and indisputable reporting of aliens and the planet where they thrive? Many in the scientific community believe that aliens on other planets are using black holes as a sort of teleportation device. This strange theory suggests that black holes are a sort of advanced quantum computer that aliens use to do everything, perhaps even travel through dimensions. Black holes have always been one of the most mysterious and magnificent space entities. These majestic and relentless space phenomena can swallow anything that dares venture into their domain, sending it into the deep abyss of their core. So far, scientists do not know much about black holes, and no one knows whether this strange theory about aliens is true or not. Another thing that makes NASA experts think about the need for advanced quantum computers is the theory that aliens might use quantum communication methods. A study by Gad Vallali and Zaza Osmanov proposes that large-scale computation could be just what would help us locate extraterrestrial civilizations. Let's imagine a hypothetical situation where an advanced alien civilization is sending signals across the cosmos. These signals could be encrypted so complexly that our current decoding methods would be ineffective. Here is where the power of quantum computers comes into play. With the ability to decipher advanced encryption algorithms, quantum computers could be the key to understanding and interpreting these alien signals. However, while the prospect of using quantum computers to explore the universe and communicate with extraterrestrial civilizations may seem exciting, there is still much to be done before this vision becomes a reality. The main challenge is to make quantum computers more stable, more powerful, and more easily accessible. Currently, most quantum computers require extremely low temperatures to work properly, and qubits are sensitive to the surrounding environment, making it difficult to maintain quantum coherence. Moreover, cybersecurity becomes a crucial concern with the advancement of quantum computers. While these devices offer incredible potential, their impact on digital security is fertile ground for challenges and risks. The vulnerability of current digital infrastructures to the computing power of quantum computers is a concern that requires an innovative solution. In conclusion, the advent of quantum computers represents an exciting and complex chapter in the history of technological evolution. While they promise significant advances in areas such as space exploration, communication with extraterrestrial civilizations, and solving complex problems, they also present challenges and concerns related to security and stability. While the future of quantum computers is still uncertain, one thing is clear: their impact on our way of living, working, and exploring the universe will be profound and revolutionary.